Welcome to this deep dive. You wanted to understand object diagrams a bit better, right?
That's the plan.
So that's exactly what we're going to do. I've got some software engineering lecture materials here. They should help us visualize these, key components.
All within UML, of course.
Exactly. So our mission today is basically to nail down what object diagrams are and, importantly, why they're actually so valuable for looking at software systems.
Right. And when we talk about software engineering itself, it's really about that structured approach, isn't it? Building, running, maintaining software.
Taking user needs and making them real.
Yeah, turning requirements into an application. It's like a transformation process. You start with inputs, go through activities, and end up with a software product.
And that whole journey, the structured path, we often call that the software development lifecycle, or SDLC.
We've touched on it before.
Yeah, we covered the phases,
Hmm.
gathering requirements, analysis, then the design phase,
Mhm.
implementation, testing, and keeping it going with maintenance.
Definitely. And for that design phase, well, there are different ways to start it. Today, though, we're really zooming in on object-oriented software design.
Right. Thinking in terms of objects that talk to each other, it's a bit different from just focusing purely on functions.
It is. It's about defining those objects and how they interact to solve the problem, all based on those core object-oriented ideas.
And to actually draw these designs, to visualize them, that's where UML comes in, the Unified Modeling Language.
It's like the standard blueprint language for software, wouldn't you say? So everyone's on the same page.
Pretty much. And UML has this whole toolbox of diagrams. We've already looked at class diagrams.
Right.
Those define the types of
The
objects.
templates, essentially.
Exactly. But today, it's all about object diagrams. Probably also mention sequence and communication diagrams later.
Which show how objects interact over time.
And state diagrams for behavior, component, and deployment for the physical setup.
Right. But before we properly jump into object diagrams, maybe just a quick reminder on how we find those objects in the first place?
Oh, good point. The noun-verb analysis trick, right?
Yeah, just look at the problem description. The nouns, the noun phrases, they often give you good candidates for your objects or classes.
Okay, cool. So object diagrams themselves, what are they officially? The UML definition describes them as graphs of instances.
Yeah, graphs of instances, objects, and data values. It says a static object diagram is an instance of a class diagram. Shows a snapshot.
A snapshot, that's the key word, I think. A picture of the system's state at one specific moment in time.
Exactly. It shows actual objects and the data they're holding right then.
So they come from class diagrams, they depend on them.
Absolutely crucial. They're both structural diagrams showing structure, but the difference is key. Class diagram is the blueprint.
Like a book has an ID, a name, an author.
Right, and the object diagram is a specific book. It's that book on the shelf right now.
Got it. So our book class might define attributes,
Mhm.
but the object diagram gives them values. It could show, say, book object 1.book,
And then it would list the actual data.
like IDE HP1026. That's a string, so quotes. Name, Harry Potter in the Deathly Hallows. Author J.K. Rowling. Real values.
Maybe price, O equals 3, 255, 0.58, QD equals 10. That's the concrete instance. Freezing time, like you said.
And there's a standard way to draw them, the notation. A box.
Yep, a rectangle. Top part has the object's identity, usually object name dot class name.
Book object 1.book. Got it.
Yeah.
Or sometimes just got class name if it's anonymous.
Exactly, if you don't need to give it a specific name in that context.
Okay. And then the bottom compartment, that's where the attributes go.
That's where you list attribute name value. So ID, HP 1026, name Harry Potter, and so on. You don't usually show the attribute types here, just the name and its current value.
Right. The type is already defined back in the class diagram. And methods, the operations.
Generally, no. Methods aren't shown on object diagrams because they're the same for all objects of that class. The diagram focuses on the state, the data values.
Makes sense. It's about what it is right now, not what it can do. And you mentioned strings and double quotes.
Yeah, standard convention for string literals.
It sounds simple, but I can see how these snapshots would be super useful.
Oh, absolutely. Especially when things get complex. Imagine debugging. You've got a problem, maybe an order isn't processing.
Oh, okay.
You could draw an object diagram showing that specific order object, the customer link to it, the payment details, all with their current values. It gives you an instant picture.
You can see the state of everything involved at that moment. Might show you exactly where the data looks wrong.
Precisely. The lecture materials mention some exercises too, right? Drawing like a library member object.
Yeah, and looking at how project and employee objects might be linked. Or modeling different payment types, card, cash, check connected to a customer.
It really shows the practical side. You're modeling bits of the real world, or at least the system's representation of it.
Taking it from the abstract class diagram to, well, concrete reality.
That's a good way to put it. You're not just thinking about a customer, you're visualizing this customer with this ID, holding these items in their cart right now.
So wrapping up, the main takeaway here is that object diagrams give us that clear, static picture, a snapshot of the objects and their actual data at one point in time.
They fill in the details defined by the class diagrams. It's like one frame from a movie.
Right, showing the state of everything in that single frame.
Which leads to a kind of interesting thought, actually. Something for you to maybe mull over.
Okay.
If one object diagram is just a single frame, a single moment, what could you learn by looking at a series of them?
Ah, like frames changing over time.
Exactly. How might a sequence of these snapshots showing how the attribute values change help understand the system's dynamic behavior, how it evolves?
Like telling a story about the software, frame by frame. Interesting.
Something to think about. How the static structure relates to the dynamic flow.